Okay, so let's review. Let's figure out what we've done so far. First, we did direct variation, right? Started off the unit on direct variation, which was just a line through the origin. So that was y equals kx, right? And this was just a line through the origin way back when to algebra. But the reason we talk about direct variation is because then we go into inverse variation. So remember, it always goes y varies directly with x, right? So the y is always going to come first. Well, then we went to inverse variation, and this is where you have that constant of variation on top. To find the k value in this case, it would be k equals x times y. All you got to do is literally have 1 point, and you can write the equation for this. To find it for this scenario, it would be k equals y over x. And once again, if it says it varies directly, all you need is 1 point. So that's where we started. This particular graph right here looks like this one. So that led us straight into our rational function, 1 over x. So now you're looking at a k value of 1. That meant that when we graphed it, we went 1, 1, and negative 1, 1. We had a vertical asymptote, a horizontal asymptote, and this curve went like this, and this curve went like this. We had a domain that went from negative infinity to 0, union 0 to infinity, and of course the range looked exactly the same. Then we took those rational functions and we moved them left to right and up and down. So then we took y equals 1 over x minus h plus k. This value right here would impact our domain, and this value would impact our range. If we had an a value that was anything other than 1, that just meant when we went from our intersection of our asymptotes, for example, say a equaled 2, instead of going from the intersection and going 1, 1, we would go 1, 2. We would go 2, 1. And we would do the same in the other direction. The bigger the a value, the further the graph got from the intersection. Then we added another piece to this one. We did y equals 1 over x minus h squared plus k. So if I go back up to this one up here, 1 over x squared just meant that both of my curves were up top. So this one acted similarly, keeping in mind that your h and k would once again impact your domain, and this would impact your range. The difference between the range in these two scenarios, this range for the parent would be negative infinity to 0, union 0 to infinity. This one's only going to be one piece. So in this particular case, the range would only go from 0 to infinity. So both your branches were going to be above the horizontal asymptote or below. And if that wasn't enough, then we went on. We've learned a lot in a few days. And we did y equals 1 over x minus some r value, x minus some r value, plus k. So now we ended up with 2 asymptotes. And say a was greater than 0, then that meant this would be up here, and this would be here. And this is assuming k is equal to 0 at this point. And then this would be down there. If a were less than 0, then you would be talking about having both these branches down here, and this one would be up here. If the r values were the same, y'all had that happen yesterday, it ended up being x minus 3 squared, that reverted back to this one, where there's only one asymptote. Okay? So now we break into all chaos with SHRATEY. So years ago, when I first started doing this, somebody had already created RATEY. But what I noticed with my students is they would always forget to do the sh part of it. So I added it to it. And so now it's SHRATEY. The first thing we have to do is simplify the equation. And this acronym, if you remember it, it'll tell you every step to go through. So when you look at this first equation, that's okay. Coughing is fine. It's all the rest that's not. When you look at this equation, the first thing we got to do is simplify it. So over here to the side, I'm going to start off with S. So my job is to simplify it. So I'm going to start factoring. If I take the 2 out up top, I end up with x squared minus 4. Everybody agree? On the bottom, I'm going to end up with 2 factors. You could do this work off on the side, whatever you want to do. What's going to happen to that x squared minus 4? Does that factor? Yes, no, maybe. It's a difference of squares, isn't it? So I have 2x plus 2 and x minus 2. And then what are my factors on the bottom? 4 and 1. Minus 4 plus 1. We okay with that? Okay. So the next part is holes. A hole would come into play if we canceled something out. In this case, are we going to cancel anything out? Is there any factor on the top that has a factor on the bottom that matches? No. So then we're not going to have any holes. So then you have R. R stands for the roots. And if you look at it, it tells you to take the top and set it equal to 0. So I have x plus 2 equals 0, and I have x minus 2 equals 0. How come I didn't set the 2 equal to 0? Does it have a variable? If it doesn't have a variable, you don't need to worry about it. So then we end up with roots at x equals negative 2 and x equals 2. So I'm going to go graph them. I kind of graph as I go. So here's my 2, and here's my negative 2. Now, when they do asymptotes, they're referring to the A stands for actually vertical asymptotes. To find the vertical asymptotes, remember, those are everywhere, but the graph is undefined. The graph is going to be undefined when you have something on the bottom you're dividing by 0. So I'm going to take my bottom, and I'm going to set them equal to 0, because I need to find anywhere that would cause me to be dividing by 0. So I got x equals 4 and x equals negative 1. So these are my vertical asymptotes. So I got to go over here to 3, 4. Bless you. And then I got to go to negative 1. So if I have 2 asymptotes, how many branches will we have? I'm going to have a left branch, a middle branch, and a right branch, correct? You'll always have one more branch than you have asymptotes. Okay, so then we have T. I'm not going to teach you about this. You'll learn about that next year in pre-cal. The next one is in behavior. In behavior is our horizontal asymptote, right? That's the one where we draw it horizontally, and as it graphs all the way out to infinity and all the way out to negative infinity, it approaches that value. Do you agree? If I go back to yesterday, you see how these are approaching 0? That was our in behavior as it goes to infinity. So when you see in behavior on here, that's what it's referring to. So let's look at our different scenarios of in behavior. We won't spend much, if any, time on top heavy. These are the 2 we're going to focus on. Bottom heavy, what it's referring to is my degree. If you were to call them 2 separate polynomials, my degree on the bottom is bigger than my degree on the top. So in this particular case, is the degree on the bottom bigger than the degree on the top? They're both the same. So in that case, we're talking about it's balanced. So then it says it's the LCs. Anybody remember what LC is? Leading coefficients. So if I go back over here and I look at my leading coefficients, it's 2 over 1. So therefore my end behavior is y equals 2. So I'm going to go up here. And now that is my end behavior, which means when I draw both of my graphs, as they go to the right and the left, they need to be approaching that horizontal asymptote. The last thing I have is y, which is my y-intercept. If you go back to the original function and you plug in 0, it'll just be your constants. So what is my y-intercept? 2. So that means I have a point right there. Notice the point is on my horizontal asymptote. Is that okay? It totally is. The horizontal asymptote is about end behavior. You can cross it. The vertical asymptote you cannot cross. Okay, so let's start trying to put stuff together. This point right here, do you agree it has to come up and grab this? And then it's going to go follow this vertical asymptote. It can't come back down. How do you know it cannot come back down? Is there a root anywhere here? You cannot cross the x-axis if there's not a root there. So it has to go up. This one's going to cross and it's going to come down and follow that one. Once again, it can't go back up because there's no root there. It could have bounced, but we're not doing anything with bouncing. So then this one over here, what do you think this root's going to do? How do you think I'm going to draw it? As I go from this root and I draw toward the right, what is it going to do? It's going to go down. It's going to go down and it's going to follow that vertical asymptote. As I draw it to the left, what do you think it's going to do? It's going to go up and it's going to follow the end behavior. So as x goes to negative infinity, it will be approaching the y value of 2. Okay, I changed my mind. I'm going to teach you together. The bottom of this is together. This thing makes you able to graph it without having to look up any points. Together, if you'll notice, talks about special squared terms. For example, if on the bottom I had x minus 2 squared, notice the factor is squared. That would mean that my graph is going to come together at that vertical asymptote. When you look at our scenario, do we have anything on the bottom, any factors that are squared? That means they will not come together at any asymptotes. So when I go to draw this right branch over here, I have a choice of it going up here or down here. First of all, can it go down here? Do you see a root? Because if I draw it down there, it's going to have to cross so that it can go there, correct? So it already can't go there because of that. But wouldn't it also come together at that vertical asymptote? Do we have anything squared? Do we have x minus 4 squared? So then it cannot come together there. So it's going to be up here. So SHRATEY makes something very complicated pretty easy to graph. And you don't have to go looking up a whole bunch of points to figure out where to plot stuff. So let's try another. Let's look at number 2. Number 2, will it simplify? I don't even have to factor anything. It's already done. Did I cancel anything out? Did anything on top, was it exactly the same as anything on the bottom? So then there's no holes, and we'll get to those eventually. We have roots. To find roots, you take the top and set it equal to 0. So I'm going to say 3x equals 0. So what does x equal? So I have a root at the origin. What do you think the y-intercept is going to be now? Yep, so I could go all the way down here to y, and I could put 0, 0. I can't get another y-intercept, can I? If I did, it wouldn't be a function anymore. So it has to be that one. Okay, asymptotes. To find the asymptotes, and this is talking about vertical, you take the bottom and you set it equal to 0. So x would equal what? 4. Subtract the 4 and then multiply by a -1. So I got 1, 2, 3, 4. Then we have tangent together. Is there anything squared on the bottom? So we don't have anything going on. So that means at that asymptote, they will be branches going opposite directions. And then in behavior. My in behavior is going to tell me what it's going to do as it goes to the right forever and the left forever. Or is this bottom heavy or balanced? Are the degrees the same or is the bottom degree bigger? Balanced, because this one's 1 and this one's 1, correct? So because of that, you take the leading coefficient. So what is our in behavior? And this is going to be our horizontal asymptote. So prior, this was our K value. So I'm going to go to 1, 2, -3. So we have 1 point to draw the left branch with. What do you think it's going to do? As I take this point and I draw to the left, where's it going to go? Could have heard a pin drop. It's going to follow the in behavior, isn't it? So it's going to come down here and it's going to follow this in behavior. As I draw it to the right, where's it going to go? It's going to go up and it's going to follow that vertical asymptote. Since we don't have anything together, where does the other branch go? Does it go above or below? Below. Keep in mind, if it went above, it would have to cross the x-axis as well. We don't have a root there, so there's no way it could go above. So those are 2 things that confirm it for you. Okay, let's try another. This one looks a lot like what we were already doing, doesn't it? So we got S. Can it simplify? We got holes. Since it didn't cancel anything out, we got none. Roots. How do I find roots? Take the top and set it equal to 0. Are there any variables on the top? So I have no roots. Asymptotes. How do I find the vertical asymptotes? Take the bottom, set it equal to 0, so I get x equals, and this one is pretty much just like our previous one, isn't it? Except we don't have any roots. T, is there anything squared on the bottom? So we're going to put none. In behavior, is this top heavy? Ignore top heavy. Is this bottom heavy or balanced? Bottom heavy. If it is bottom heavy, that means it's y equals 0. And this should be familiar to you because this one is just like our HK ones. And then I need a y-intercept. If I plug in 0, what do I get? Three-fourths. So at 0, I have a point right here. So from this point, as I draw to the left, what's it going to do? Follow the in behavior. As I draw to the right, it's going to curve up with that vertical asymptote. Now, where does my right branch go? Is there anything squared on the bottom? Any factors squared? So then it cannot come together at that asymptote, so it has to go below. And that one's like the one we've been doing the past few days. Ready to try another? If I simplify this one, I'm going to take that -2 out in front. That's going to give me x minus 2. I just swapped the order a little bit. And then on the bottom, I can't do anything with that. It's 2x minus 3. Is there anything I can cancel out? I can't cancel out the 2 because I can't factor it out. So nothing's canceling, so no holes, none. Roots. How do I find roots? Set the top to 0. So I get x equals 2, bless you. Asymptotes, how do I find the vertical asymptotes? Set the bottom to 0. So I get x equals what? 3/2. So this asymptote is pretty much right by this root. Is there anything squared on the bottom? So they won't be together. End behavior. Bottom heavy or balanced? So then I can go right here. And what's my end behavior? So I go down here and draw my horizontal. Yeah, because you got -2/2. Then we have a y-intercept. If I plug in 0, what do I get? Bless you. -4/3. So that would be like right here. Okay, go ahead and graph it with your group. See if y'all can figure out how to graph it. My left branch is going to come up and follow that in behavior. It's going to go over and follow the vertical asymptote down. My right branch is going to follow that vertical asymptote, and then it's going to come over and follow the in behavior. We okay with that? Okay, we've got a couple more to try together. And then the other page we save for tomorrow. So looking at this one, if I simplified, I would have the top is already simplified. What about the bottom? If I take out the 6, what am I left with? Isn't x squared minus 1 a difference of squares? So I get x plus 1 and x minus 1. What in the world? So, do you have anything on the top that'll cancel with the bottom? So therefore, we don't have any holes. We don't even know what a hole is yet. We'll figure that out soon enough. So then we got asymptotes. See if you can figure out what the asymptotes are. Oh, whoops, sorry, roots. I skipped one. R, roots. Thank you. I'm multitasking here. It's not working. Did you get 2? I see 2 roots. 3x equals 0 and x minus 4 equals 0. So I got x equals 0 and 4. If I got a root at 0, 0, what's my y-intercept? So I can go ahead and write that. Okay, with your group, see if you can figure out what the asymptotes are. Keep in mind, these are the vertical asymptotes. The horizontal will be in behavior. So you've got x plus 1 equals 0 and x minus 1 equals 0. I don't need to worry about the 6 because there's no variable, which is going to give me a positive and a -1. So I've got a vertical asymptote right here. And I've got a vertical asymptote right here. How many branches are we going to have? 3, left, middle, and right. So then T, when you look at it, do you see anything squared? Any of the factors being squared? Are you sure? X squared is not, this is X plus 1, this is X minus 1. Are they squared? So then none, which means none of our graph will come together at those asymptotes, which is going to help us know which way to graph it. In behavior, is it bottom heavy or balanced? Are you sure? This right here is 3x squared over 6x squared. Balanced? So then what is my in behavior? Good. So I'm going to put an asymptote right there, a horizontal one. Remembering we can cross the horizontal asymptote. The horizontal asymptote tells us about end behavior. What's going to happen is it goes way out to the right and way out to the left. So starting with I'm going to start with the right root, this one right here. As I go out to the right, what's it going to do? It's going to come up and follow this end behavior. As I take it to the left, it's going to come down and it's going to follow that vertical asymptote. Now I have a root right here. This right here tells me how to graph it. Will the graph come together at the asymptote? So therefore, when I go off to the right of this root, what direction am I going? I got it down. If I draw it down, aren't they going to come together? This would be coming together. You see how they come together at that asymptote? But we don't have anything squared, so it has to go up. So that together thing will tell us if they come together. Now, as I go to the left on this root, what's it going to do? It's going to go down. And the reason I know that is because if you look at the top, is there anything squared? You remember how we had multiplicities of 2? It would bounce at the root if there was a multiplicity of 2. Now I have one more branch to draw on the left. Will they come together at this vertical asymptote? No, I don't have any x plus 1 squared. So therefore, will it be down below the horizontal asymptote or above? So since they're not going to come together, it's going to go up here. Okay, we got one more. Simplify. I got a 3 on the top. So do I have any roots? Nope. Okay, talk to me about the bottom. What do you see? You see 2 terms. Do you have 2 terms? Do you have a difference? And do you have squares? So a difference of squares. What's the square root of the first term? What's the square root of the last term? 9. So 3. And then you get a plus and you get a minus, right? Okay, well, anything on the top cancel out with anything on the bottom. So we have no holes. Still don't know what they are. Then we have roots. Do we have any roots? Nope. There's no variables on top. Asymptotes. If we take the bottom and set them equal to 0, what do we get? Plus or minus 3/2. So I'm going to go over here and I'm going to do 1, 2, and I'm going to draw an asymptote in between. -1, -2, draw an asymptote in between. How many branches are we going to have? 3. Okay, so for my t, do I have any factors being squared? So none, which means they will not come together at any of those asymptotes. In behavior, bottom heavy or balanced? And if it's bottom heavy, what is it? Y equals 0. Good. And then y-intercept, if I plug in 0, what do I get? So this right here. Okay, let's start with the middle. I have a y-intercept. Do I have any roots? So therefore, it cannot go up because it cannot cross the x-axis. So both of these pieces have to come down, or both of these sides have to come down and follow the vertical asymptote. You cannot cross the x-axis unless there is a root there. Do we have anything telling us that the branches are going to come together? So therefore, both of the other branches have to come up here. And this was actually like the ones we did yesterday, where the A value would actually tell you that both those branches would be up. You okay with that?